Hey everybody, welcome back to our next video in our Android Starter course. So in this video, we're going to talk about something called object-oriented programming. And we're going to start off by just talking about what is a class and how we can use it to make objects. But before we get to that, let me just add some code in here. So if in the code I want to, let's say I want to represent a car, well, I can do that just by making several variables for all the different pieces that I need, all the different pieces of information that I need about that car. So I can say like val brand equals, let's say we can, Renault is going to be my car brand, and my model, val model, val model equals driver. And well, I should track the year of this car, so val year equals let's just say it's 2020 is fine. And let's say I want to have another variable here to track if this is a diesel or not. So val is diesel, and I'm going to set that equal to false. Well, now I have a bunch of different variables here that are all going to represent my car, but let's say I want to have another car. Well, how do I do that? Well, I got to make a bunch more variables, so I can say val brand2 equals Suzuki, val model2 equals Swift, and I can just keep going on like this. But you can see how tedious this is going to get for every, not 2015. You can see how tedious this is going to be for every single car. Plus, whenever I want to delete one of these, I have to get rid of all the variables, or whenever I need to pass it into a function, I need to pass all this data individually to a function, and that is just not going to be a sustainable solution. So instead, what I'm going to do is I'm going to essentially take all of these data points here, all of these variables, and I'm going to define them instead of just here within my onCreate function, which is the code that's going to run. This is your starting point for your Android application. So instead of just putting them all in here, what I'm going to do is I'm going to make a separate class, which is essentially going to just be a blueprint for objects that we can create from that class. And more or less what we're doing here is we're defining something that's going to behave very similarly to our primitive data types that we've been using before. So I'm going to come over here to my package, click New, Kotlin class or file, and I'm just going to make a file called car, and make sure you have class selected here. Well, now I have this class car, and what are you looking at here? So basically, you have class is the keyword here that's defining that this car is going to be the name of our class, and then everything between these two curly brackets is going to be the main code of our class. But also, just like a function, you can pass data to a function by putting a parameter list inside of your parentheses here. You can do the same thing with a class rather, and that's exactly what I'm going to do. I'm going to say val brand, and I'm going to make that a string, and I'll say val model, and that's also going to be a string. And then val year, I'll make that an integer just because that's going to be a number, so we'll store that in a number instead of in a string variable. And then I'll have another val down here for is diesel, and I'll have that be a Boolean. So basically what I've done now is I can come back on over to main activity, and instead of doing all of this, what I can do is I can say val car1 equals car, and then within the parentheses, all I need to do is just say brand equals Renault, comma, model equals Triber, year equals 2020, and then is diesel equal false. So this has created a car object for me, and now if I come down here and I just let's say I make a new object, or let's say I want to change one of these values. I can say car1 dot, and now you can see I have is diesel, brand, model, and year. So now all of these data fields in here are going to be wrapped up in this single car blueprint. And when I create an object using this class or this blueprint, I've essentially created an object that has a data field for each one of these variables inside the blueprint. And you don't need what's in blue here. Technically, I can just say Renault driver and then a number for the year that is diesel. But you'll see Android Studio actually puts a little gray label there. I just like to have the blue labels. That's a Kotlin specific thing, but you don't need that per se. Now, we also don't need this. We don't need a separate variable for each car. And if I want to have several different cars here, I can do that just as easily. I could say val car2 equals, and then car, and within here, I could say Maruti Suzuki, and that's going to be a Swift model, and then this is going to be 2020. Or let's make it a little more interesting, 2010. Okay, and you'll notice I have a red here. Well, that's because in my car, I have 1, 2, 3, 4 different data fields, and here I'm only passing in 1, 2, 3. Well, so because this is diesel field is more often than not going to be false, and really I only need to specify that in the rare case that it is a diesel. What I'm going to do is I'm going to set a default value so that if we don't specify that, it's going to default to false. And the way that you do that is right here inside these parentheses, which is in Kotlin called your primary constructor. In here, just after the data type, you just say equals false. And now, if you go back to your main activity, you could see that even though I don't have the is diesel field there, it's still going to default to false, and that data has been provided by the template itself with the default value. So I don't have to actually put that. And by the way, this declaration up here, where I have them each on a separate line and with a label, is going to work the same as this declaration down here. It's just the spacing and the return lines are different. But really, if I wanted to make that look the same, I could add all of these in as well. And now it would look something like this, and I can add the labels on there. So brand equals, model equals, and then year equals. And typically, these are going to look, it looks a lot cleaner when you do it like this with all the labels. So I tend to do it that way, but definitely just be aware that it works if you have it all just jammed together on one line as well. So now coming back to my car. Right now, I have a class with a bunch of variables and nothing inside these brackets. So technically, this could be considered a data class if I add the word data here. And essentially what that means is I have a class or a template for an object that is only going to contain variables, right? I don't have any functions in here. And data classes are good for storing objects in libraries or in databases or for reading things down from network calls and pulling data out of network requests. Data classes can be really helpful for that. But we don't actually want this to be a data class, so I'm going to add these curly brackets back on the end, and let's look at some different functions that we could add here. Okay, so the first one, I'm going to put a global variable up here, and actually, maybe within the class, I'll put another, right in here, I'll put another variable, and this is just going to be val tag, and this is just going to be a tag for all of my log messages, and I'm just going to call this car.kt. And just note here, you can have variables inside of these curly brackets, and you can also have variables inside of your constructor, so inside of the parentheses. if you have variables down here, you have to provide a value. Whereas if you have variables up here, you can provide a value, and that'll be considered the default value. But if you don't provide a value, that value will be provided whenever you make that variable, or whenever you create that object in the code. So coming back down here, we have our tag. So I'm going to add just a couple different functions in here. So let's say a few things that a car can do. A car can accelerate. And in here, all I'm going to do is write to the log. And I'm going to go ahead and say, whoops, let me import that. I'm going to say tag and then the $brand, $model, just because that's how people refer to cars, right? Like if this was a Jeep Wrangler, this would then print out the Jeep Wrangler. So that's the way people talk about cars. So is accelerating. And then let's make another function down here for braking or decelerating. And same thing here, we're just going to write to the log. And I'm going to say log. We're going to pass it that tag variable, which is that car.kt string that I made. And then in here, I'm going to do the same thing, the $brand, $model is braking. Whoops, we need a .i on the end of that. Okay, there we go. Now if I come back to my main activity, I've got both of these cars. And with both of these cars, if I use my dot operator, meaning if I push dot after the name, so car2 dot, and then I say accelerate, I can call this function, this accelerate function, I can call from my main activity, or really from any activity where I have a car object, I can call that function. So this class, I said it's a blueprint for an object, and it is that. It's going to contain all of the different data that you need for that object, or all the different data fields rather. And then it's also going to contain all of the associated functions to that object. So here we have accelerate. If you wanted to run car2.brake, you could do that too, or even car1.accelerate. Right, like both of these objects, because they're both of type car, they're going to have access to all of these data fields, which will be unique to each car object, or each instance as they call it. So this car1 is going to be an instance of the car class, and this car2 object is going to be another instance of the car class, and both of them are going to have different data. They don't technically have to, but here they do have different data, right? This is a Renault Triber 2022. This is a Maruti Suzuki Swift 2010. So this data is obviously different. And if I were to run this code and filter on my car.kt, that's that tag variable that I used. You can see here we have the Maruti Suzuki is accelerating, the Maruti Swift is braking. Oh, sorry, I read that wrong. The Maruti Suzuki Swift is accelerating, which that's this line of code, car2.accelerate. The Maruti Suzuki Swift is braking, that's this line of code, car2.brake. The Renault Triber is accelerating, that is going to be this line of code, car1.accelerate. So each object here, which is an instance of the car class, has access to all of the data defined within it. And then also it has access to, where did that go? It has access to all of the functions within it. Well, let's add another function here. Let's say we live in the city of Delhi, and in the city of Delhi, a car is only going to be valid or legal to drive. If it's a petrol car, it's only going to be legal to drive for 15 years after production. And if it's a diesel car, it's only going to be valid to drive for 10 years after production. So let's add a new function here. Fun is are valid. And I'm just going to have this return a Boolean. So within this function, we just need to determine if this car is valid to drive on the streets of Delhi. So a petrol car you can drive for 15 years, and a diesel car is only going to be valid for 10 years, and then after that you're not going to be allowed to drive it in Delhi. So what I'm going to do is I'm going to say val rather, max age, meaning the max age of the car, is going to be equal to if is diesel, then 10, else 15. Else meaning if this is not a diesel car, if this is a petrol car. Then under that, I am going to get the current year. So I could just obviously code that in for right now. Current year equals 2023. But there's actually a better way to do that in Kotlin. So instead of just setting it to the current year, say calendar dot get instance dot get calendar dot year. And essentially, this is going to return the current year. So this will be 2023. And right now, that would be the same if I just typed in the number 2023. But next year, if I were to come back and run this code, well, then if I just typed in 2023, then it would still say 2023 next year and the year after. But if I say this, well, the next year it's going to say 2024, and the year after it'll say 2025. So this is a much better way of getting our year for our code. And then after that, we need to essentially determine how long or what year our car is going to be valid until. And that is pretty easy to do. We can say valid until and set that equal to the current year plus the max age. Or sorry, not the current year. That won't work. The year of the car plus the max age. Technically, I think it's the year the car was registered for the first time, not the year the car was produced, but whatever. I'm going to leave that as year here. So valid until year plus max age. And then down here, all we need to do is have an if statement, and we can say if valid until, so the year that this car is valid until is less than or equal to the current year. Well, then I'm going to write a log.i, and we're going to tag $, or we're going to say the $year, $brand, $model is expired, else we're going to say the opposite of that. The $year brand model is still valid. Okay, did I get that right? If valid until is less than or equal to the current year. If valid until is less than the current year, then this is expired. Otherwise, it is not expired. Also in here, we're going to return false, just because this function returns Boolean. So we need to return either it's true or false. And then down here, when it's still valid, I'm going to return true. So now I could take that and I could come back to my main activity. Whoops, my main activity. And let's say this is actually not a 2010, but a 2001. And if I come down here and say car one dot is car valid, let me update that. You really want to have what we call lower camel case, which is the beginning of the function is lowercase, and then every next word in the function is going to be capital. So I'm going to say is car valid with a capital C and a capital V. And then back in main activity is car valid. And then down here, car2 dot is car valid. And now let's go ahead and run that again. And we get all those same three codes, and you see the 2020 Renault Triber is still valid, and the 2001 Maruti Suzuki Swift is expired. So that is doing exactly what we want it to, and we've successfully created two car objects with our car class or a blueprint. But every once in a while, you might have some technological innovations or just reasons to want to create a different type of car that is going to share a lot of the same data, but not necessarily all of it. Well, luckily, in Kotlin, and actually in most programming languages, you have a way to do this. This is called inheritance. So I can come over here, I can make a new Kotlin class or file. Let's make that a class, and we're going to call this one electric car. And within this electric car class, well, I'm going to want a brand still. I'm going to want a model. I'm going to want a year. But this is diesel. Like that's pretty much always going to be false. You know, I'm never going to have a diesel electric car unless you have a really odd hybrid. But anyway, our car needs to accelerate. It needs to brake. And then this is car valid. We're going to have to do something different with that because if we're checking for diesel cars and for petrol cars after how many years are going to expire, well, an electric car is not going to be subject to those same laws. So this electric car is not going to expire ever. So if you come back over to the electric car, what you can do here is if you do a colon and then car, kind of like how we're specifying a data type, we're saying this class is going to inherit from this class. And what that means is this is now going to be it's going to be called a child class of our parent class car. So if this is our parent class car, well, all of the data down here and all of the functions down here, our electric car is going to inherit just outright, but all of this data are, because it's inside of the constructor, right, and that's something that we have to specify, well, our electric car is going to have to provide that data. So the way I'm going to do that is I'm going to do two sets of parentheses here, and that's going to be the constructor for the electric car. And then this, think of it just like calling the constructor for the car. So basically, what we're going to need to have here is all of the data that we care about. So inside the electric car, we need a brand. That's going to be a string. We need a model. That is also going to be a string. And then we'll need a year, which is going to be an integer. And then even on the car, even though on the car we need this is diesel, on the electric car, I know for a fact that because it's electric, this is not diesel, so that's going to be false. So then I need to pass these pieces of data into this car. And basically, all I have to do is say brand, model, year, and I'm going to pass it false. Well, I can pass it false because in here, this is diesel is always going to be false for an electric car. But actually, because our default value is false, I don't need to give it that piece of information there. And then also, you'll see it's highlighted red here. And if you look at what it says this type is final, so that it cannot be inherited from. Make car open. So essentially what this means is in Java, you have something called final, a final class or a final variable, which means, or a final function, which means this is something that we can't override and we can't inherit from. It would make that essentially the end of the tree. But in Kotlin, everything is going to default to final unless you specify otherwise. So when it says class car, this is really the same as if this was Java. It'd be like saying final class jar or final class car. But we don't want this to be final. We want this to be open, meaning we can inherit from that. So now if I come back to electric car, you can see that error has gone away. And if I were to come over to my main activity now, and I've got car 1, car 2, let's say we're going to make a val car 3. So val car 3 equals, and this is going to be an electric car now. And in here, I'm going to say brand equals Tesla, model equals Model S, and then year equals, I don't know, 20, year equals 2018. So now down here, I've got my, actually let's set that a little older just so we can look at stuff. So maybe 2002 is going to be our electric car model. So down here, if I look at car 3 dot, and then I say, like, you can see we've got is car valid, brake, accelerate. We have all these same functions. And even I could come in here into my electric car and I could define new functions here. So I could say fun, charge, battery, then log.i, whoops, log.i, alt enter to import, tag. And notice I can use tag here, even though this tag is a member of the car class. I can use it because my electric car, when I inherit from car, I'm inheriting all of these functions, everything between this curly bracket and this bottom bracket. So all of these functions and the variables, I have access to all of those. So I can use that tag, and then in here, I can say the $ brand $ model is charging. And also, one more thing, this tag, if you look here, it says car.kt. Well, that's the name of my file. So what if I wanted this tag variable? I still want to use it in my electric car, but I want it to say maybe electric car.kt instead. Well, I can do that just like in this car class. I've marked it open. I can mark this one open as well. So open val tag equals car.kt. And now I can come into my electric car and I could say override, which means I'm overriding the value of tag. And I'm going to say, whoops, I shouldn't have done that. I'm going to say override val tag equals, and in here, I'm just going to set it equal to electric car.kt. And now let's go ahead and say car3 dot charge battery. Or I could say car3 dot is car valid. And now let's run that program one more time. And you can see I get all these top ones are all the same. And then you see the Tesla Model S is charging because we're running that car3.charge battery function, and then car3.is car valid. You see our 2002 Tesla Model S is expired. I don't even know if they were making, I don't think they were making this Tesla car in 2002. But let's not worry about that. Let's worry more about why is it expiring? Because if I have an electric car, theoretically, the law says, in Delhi at least, that if you have a petrol car, you're good for 15 years, and if you have a diesel car, you're only good for 10 years. But I'm pretty sure if you have an electric car, you're good just indefinitely. So this electric car, because we're inheriting from car, we get all of these traits, and we get all of these, we get both of these functions that we want and that we can use, but we also get this is car valid function. And this is going to be a problem for us. So what could we do about this? Well, just like we put open in the val, or on the tag variable, and then we did override val tag and set it equal to electric car, we can do that same thing with this function. So we can say open, and then over an electric car, I could say override fun is car valid. And instead of doing this return super, what I'm going to do is I'm going to come over here and I'm going to copy the still valid, because this is always going to be still valid as long as it's electric car and that law doesn't change. And I'm going to say the year brand model is still valid. So now this is going to say the 2002 Tesla Model S is still valid. So if I clear this out, come back to my main activity and run this one more time. Now if you look here, you can see we've got all of that stuff. And then finally, the 2002 Tesla Model S is still valid. So even though this is 21 years old at this point, because we overrode that function, this car function, whereas before when it hit this is car valid function, it returned it's expired because it was too old. But now, because we've overwritten that function, this is turning back that the car is still valid. So this is going to be more or less exactly what we want. Just one more thing that I'll mention while we're in here is you'll notice that like car3, for example, car3 dot, it's got a accelerate function, it's got a brake function, and it's also got a charge battery function. So it has access to all of the functions that we defined within the car, accelerate and brake, and then is car valid, which we overrode. And then it also has this charge battery function. But if I look in here and I go like maybe car2 dot, and I see brake, I see is car valid, but if I try to charge battery here, I'm going to get an error because that function is not defined for the car data type. It's only defined for the electric car data type, which is inheriting from the car. So another thing I'll show you is if I hover over this electric car and I push Control H, it'll open up this window over here, and it's going to show me that electric car is inheriting from car, which is inheriting from object, java.lang object. So this is what we call the hierarchy. Now, if you come back over to, or even up here and click on maybe app compact activity and do a Control H, you could see these hierarchies get a lot longer than that. But just for what we're doing in this class right now, just know that Control H here will give you your hierarchy for all of the objects that we've defined, and it's going to be a nice, clean, short list. So hopefully this has made sense to you, and we've been able to show you how we can build a class, which is essentially going to be a container for your different variables and functions that we want to associate together. And then we can use that as a blueprint to build objects from. So for example, here we're building car objects. And then also we talked about how we can inherit from those classes that we've created. So like here, electric car is inheriting from car, and it shares all of the same data and all of the same functions, and it can implement its own functions as well. Hopefully this video has been helpful for you. Definitely like and subscribe to our channel, and stay tuned for additional content that will be coming out your way. And we'll see you in the next video.